Hello everyone, welcome back. So in last video we learned about bubble sort. Now in this video we will learn about insertion sort. Insertion sort is a pretty cool algorithm. It is how sorting is done in real life. So imagine you are holding playing cards and you have to arrange your cards. You pick up one card at a time and put it in the right spot in your hand. That's basically insertion sort. You take one element, find where it should go in the sorted part and put it there. Simple as that, right? Let's understand this deeply with an example of array. So let's take an array 5, 9, 1, 4, 3. In this array, we consider this as sorted part of the array and this as unsorted part of array. Now we'll take an element, let's name it as key, which is 9, right? So we'll take this element and find its place into the sorted array. So we will compare 5 with 9, but since 5 is lesser than 9, so there won't be any shift that is going to happen here, so it will remain like this. Okay, so our array will remain like 5, 9, 1, 4, 3, right? And now this becomes sorted part and this become unsorted part. Okay, now the key element will be 1, this element. So now we will find the place of 1 into our sorted array, right? So we'll compare 9 with 1. Since 1 is lesser than 9, so the shift will happen, right? So here the shift will happen, this becomes 9. Again, we will compare our key with the next element, which is 5 into the sorted array, right? So again, 1 is lesser than 5, right? So again the shift will happen. Now this becomes 5. Now we have found the place for our key, so we will do this swapping. Okay, so after this pass, which is pass 1, right? First was pass 0. So after pass 1, our array looks like 1, 5, 9, 4, 3, right? Now this becomes sorted part and this becomes unsorted part, right? Now let's take key as 4. Key is always the first element of unsorted array. Okay, so we'll find the place of 4 into the sorted array, right? So we'll compare 4 with 9. Since key is less than 9, so what we'll do, we'll do the shifting. So this becomes 9. Again, we'll compare our key with 5. So since 5 is greater than the key, again shift will happen. 9 becomes 5. Now again 4 will be compared with 1. Now here, since key is greater than the element here into the sorted array, so now we stop here and we do the swapping, right? Because we have found the place of our key. So after this pass 2, our array looks like 1, 4, 5, 9 and 3, right? Here this one is sorted array and this is unsorted, right? Now let's go for the pass 3, right? So after pass 2, our array looks like 1 4 5 9 3, right? This is pass 3, right? So here obviously key will be 3 because this is sorted and this part is unsorted. Now we have to find the place of 3 into our sorted array, right? So we compare 3 with 9. Since key is less than 9, shift will happen. This becomes 9. Again 5 is compared with 3. Since key is less than 5, again shift will happen. This becomes 5. Now again 4 is compared with 3, right? So again key is less than 4. So again shift will happen. This becomes 4. Now since key is greater than 1, so this swap will happen here, right? So after this pass 3, our array looks like 1 3 4 5 9, right? So our array is now sorted, right? This is sorted array. Now if we look at the time complexity here, so if you see here, one iteration we are going for the elements to traverse through the array, and second traversal we are doing into the sorted part, right? So this is nested loop that we'll see obviously in code implementation. So the time complexity here is n square. This is the worst case. But if array is already sorted, obviously no shift, no swap is required, right? So in that case, it will be big of n. So best case scenario, big of n, worst case, n squared. Average case will be big of n square. Space complexity, since we are not using any extra space here, we are just shifting and swapping the element here. So space complexity will be constant here. Okay. So this is how insertion sort looks like. Now we will go to our code editor and try to code it in Java. Okay. So now let's create one class for insertion sort. Insertion sort, right? Now let's create one method, main method for insertion sort here, and let's create one array which will sort, right? So let's take same array 5 9 1 1 4 3, right? And we'll create one method insertion sort, right? And we'll pass array to it. Second method will obviously print array, right? So print the array. Now let's create these two methods, public static void insertion sort. It will take input as array, right? And also we'll create another method which will be print array, right? So first let's implement this print array. It will iterate through our array, right? And it will system.out.print. It will print the element plus it will have space, right? So printer is done. Now let's come to our insertion sort. So first for the outer loop, we'll add for int I will start from 1 because we will obviously consider the key element starting from the 1, right? So I will start from 1, then I is less than array dot length I plus plus, right? Now let's take the key element, which is obviously array of I, so it will be array of I. So our key element will be array of I, and obviously to iterate through the sorted array we have to take j, right? So j will be I minus 1, right? Now what we'll do, we'll take our key element and we'll compare it into the each element of our sorted array and see where we can place our key element, right? That's what we are going to do. So let's write a while loop to iterate through the sorted array. So while, and in the while we will check two things. One, where to stop the comparison in the sorted array. So for that we have to just check if j is greater than equals to 0, and also we'll check array of j is greater than key, right? So we'll check two things. So we'll iterate through the sorted part of the array and then we'll compare that if key is less than array of j, right, and j is greater than equals to 0, then the shift will happen, right? Shift will happen, right? So how will shift? Obviously array of j plus 1 equals to array of j, right? And also j minus minus, right? So once we find the position of our key element into the sorted part of array, then we will come out of the while loop, right? And we'll do the swap, right? So we'll do array of j plus 1 equals to key, right? So now let's try to execute this class. So you can see now array is sorted, right? So this is how you can implement insertion sort, and you can obviously see, right, we have this for loop and then inside we have this while loop, right? So this includes two nested loops. That's why the time complexity, average time complexity of insertion sort is big of an square, and it is better than bubble sort. Why it is better than bubble sort? Because in each pass we are doing only once swapping, right? While in bubble sort we had to do a lot of swapping into a single pass also. So we are doing here shifting, and then when it is when we find the place for our key element into the sorted part of array, then only we do the swapping. So it is better than bubble sort. Okay, so this is how insertion sort is implemented. Hope you have liked this video. If you have liked the video, please subscribe our channel. In next tutorial we will learn about selection sort.